Okay, in the last video we looked at some examples of exponential growth and decay. We're going to look at one or two more examples of exponential decay here. In this case, we're going to talk about what's called half-life. Uranium-238 has a half-life of 400 years. I'll point out I'm just totally making that up for the purposes of this problem. Don't go check a chemistry book because I'm just making this up. If I start with 100 grams, when will I have 20 grams left over? And in order to solve this, we have to understand what half-life is. Essentially, half-life tells you in this amount of time, 400 years, I will have half of what I started with. One way to get an idea of what the solution to this problem would be is to create a table. So let's see. When time equals 0, I have 100 grams. Half-life says that when time is 400, I have half of what I started with. Half of 100 is 50 grams. But then 400 years later, so when time is 800, I have half of that, which is 25 grams. 400 years later, which is 1,200 years total, I have half of 25, which is 12.5 grams. And it would keep on going like that. Which means, if you kind of think about it, let's see, if I start with 100, when will I have 20 grams? Well, in 800 years I have 25. In 1,200 years I have 12.5. So my answer should be right in here, somewhere between 800 and 1,200. Now I just want to refine that down. It's an exponential decay problem, so we go back to our standard equation. A equals A initial e to the kt. Let's see, my initial value is 100 grams. So A equals 100 e to the kt. And now, just like before, I need an A and a T that are related in order to find K. The problem is there's nothing really explicitly stated like there were in the last few problems we did. But if I know what half-life means, that's what? When time is 400, I have half of what I started with. That gives me another point I can use. I can plug in, when time is 400, that's the half-life, I'll have half of what I started with. Half of 100 is 50. And now I have an equation I can solve. Do all the algebra just like we did last time. Divide by 100. 50 divided by 100 is a half. A half equals e to the 400k. Now, how do I bring down the power? Take the natural log of both sides. ln of 1/2 equals 400k. And then divide by 400. And I get that k is equal to ln of 1/2 divided by 400, which is negative 0.001733. Negative 0.001733. Now I have my k. Now I'm right back where I was in the problems we did before. Take my original equation and plug in k. A equals 100 e to the negative 0.001733t. And solve the question I want. Let's see. When will I have 20 grams left? I'm looking for time when I know A is 20. So 20 equals 100 e to the negative 0.001733t. And do all the same algebra we did right there. Divide the 100. 20 divided by 100 is 0.2. So we get 0.2 equals e to the negative 0.001733t. Bring down the power. Take the natural log of both sides. ln of 0.2 equals negative 0.001733t. And then divide by right that. So negative 0.001733. And that will be my t right here. Really quickly. We get time equals 928. So 928 years. And, well, let's see. Over here we said I should end up somewhere between 800 and 1,200 years. I got 928. So we're good. It worked. There's one more half-life problem I want to look at. So let's see. Let's see, we will say half-life of carbon-86, again, I'm just making this up, don't go look in a chemistry book, is 200 years. When will I have 30% of my initial value of carbon? Carbon-86. Half-life of carbon-86 is 200 years. When will I have 30% of my initial value of carbon-86? It's exponential decay, so I have my standard problem. A equals A initial e to the kt. The problem here is I didn't actually give you an initial value, but there are different tricks you can do. The easiest trick maybe, if you don't like doing a lot of algebra, pick a value for A initial. If I don't give you one, you can just make one up. Go with 1 because it's probably the easiest. So let A initial equal 1. Then you're left with A equals e to the kt. Now, well, I know the half-life is 200 years, so do what I did in the last problem. When time is 200, I have half of what I started with. If I started with 1, half of 1 is a half. And now just solve it out just like we solved the last one. ln of both sides, so ln of 1/2 equals 200k. And then divide by 200. And that's your k. I'm not going to put that into the calculator because we don't need it right yet, because there's a point to this. What if instead of using 1 gram as an initial value, because I just made that up, I used 6? Well, then I would get A equals 6 e to the kt. If I then use my half-life, I would get A equals 6 e to the 200k. But when time is 200, that's the half-life. I have half of what I started with, which is 3. And now to solve for k, I take the divide by 6. You get 3 over 6, which is 1/2, equals e to the 200k. ln of both sides. ln of 1/2 equals 200k. And then divide by 200. Which is exactly what we got right here. And the point is, with half-life, it doesn't matter. You can pick any initial value you want. Personally, I prefer to let A initial just be A initial. And then when time is 200, I have half of what I started with, which is 1/2 of A initial. Then you divide by A initial, they cancel, and you're left with 1/2 equals e to the 200k. Same as we got here, same as we got here. It doesn't matter. You can use whatever one you want. Ultimately, with a little bit of practice, you recognize the k value is ln of 1/2 divided by the half-life. It's true there, true here, true on the last one we did. Which means, when you kind of understand what's going on, you don't necessarily have to do all the algebra for half-life. K is ln of 1/2 divided by the half-life. So now, we can solve the problem out. Let's see. What is ln of 1/2 divided by 200? Negative 0.003466. Negative 0.003466. That's my k. Rewrite my problem. A equals A initial. Just make it 1 again. E to the negative 0.003466 t. And now let's see. When will I have 30% of my initial value of carbon-86? I'm looking for time t, which means I need an A. But that's 30% of my initial value. Since I let my initial value be 1, I just need 30% of that, which is 0.3. So I get 0.3 equals e to the negative 0.003466t. And now do the exact same math to solve for t. Take the ln of both sides. ln of 0.3 equals negative 0.003466t, and then divide by k again. Negative 0.003466, and there is my t. And one last time, ln of 0.3 divided by negative 0.003466. 347 years. Okay, and the point of this is, in the last video and in this video, we did exponential growth and decay. They're both the same, and they're both solved the same way. Take your original equation, a equals a initial e to the kt, plug in what you know. If you're not given an initial value, you can just make it up, call it 1. Then use the information you're given for a and t to get your k, and then once you have your k, plug it back in, do the exact same algebra to solve for something else. I might do a video with one more application of exponentials. I'm not sure if we really need it, but I might do it just for fun.